the simple gas turbine cycle with a regenerator. The efficiency of the gas turbine cycle may be improved by the gas turbine cycle may be improved by introducing a regenerator. A simple open-cycle gas turbine cycle with a regenerator is shown in the picture provided here. And the corresponding ideal air standard cycle with a regenerator is shown on the PV and TS diagram. In the cycle 1 to X 1 to X 3 4 Y and Y. The temperature of the exhaust gas leaving the turbine in state 4 here is higher than the temperature of gas leaving the compressor, this point. Therefore, heat can be transferred from the exhaust gases to the high pressure gases leaving the compressor at regenerator. In this point, we have heat exchange If this is done in a counterflow heat exchanger and regenerator, the temperature of high pressure gas leaving the regenerator Tx, this point. Maybe in the ideal case have a temperature equals to the T4. At the inlet we have Tx equals to T4. The temperature of the gas leaving the tube. Heat transfer from the external source is necessary only to increase the temperature from Tx to T3. Here. Heat transferred in. Area X3 dBx X 3 T AX area, this area, represent the heat transfer. And the area Y1ACY Y1 AC and Y represents the heat reject. Heat transfer. The influence of pressure ratio on the simple gas turbine cycle with the regenerator is shown by the concentric angle 1, 2 prime, 3 prime, 4, 1. The influence pressure ratio. Considering the increase into the 1, 2 prime, 3 prime, 4, 1. In this cycle, the temperature of exhaust gas leaving the turbine is just equal to the temperature of the gas leaving the compressor. Here, point 3. Therefore, utilizing a generator is not possible. This can be shown more exactly by determining the efficiency of the ideal gas turbine cycle with a generator. The efficiency of this cycle with the generator is found as the relation the efficiency of the cycle eta thermal QH CP33 minus T4 WT equals to CP T3 minus T4. This is TX. Part 4 an ideal regenerator T4 equals to TX. Consider this picture. And for this relation we have QH T4 equals to Tx for ideal one. In this case, QH equals to WT. So for ideal, W compressor on WT. W compressor is T1, this T1, this part, and CP T3 minus T4. You can write various relation here. Eta can be also expressed as or we can write thus, for the ideal cycle with regeneration, the thermal efficiency depends not only on the pressure ratio, but also on the ratio of minimum to the maximum temperature. Efficiency is a function of, for example, pressure ratio, We note that in the contrast to the Brighton cycle, the efficiency decreases with increase in pressure ratio. Efficiency decrease with increased pressure ratio. Opposite to Brighton. The effectiveness of efficiency of regenerator is given in the picture in the next page for more description. The effectiveness efficiency of a regenerator is given by regenerator efficiency, which can be best defined as the difference in the picture provided here. State X represents the high pressure, which can best be defined with high pressure gas leaving the generator state. X in the ideal regenerator, therefore, would be only an infinitesimal temperature between the two steams, and the high pressure gas would leave the regenerator at the temperature Tx prime, and Tx prime equals to T4. Ideal case, which in an actual regenerator, which must operate with a final temperature difference Tx, the actual temperature leaving the regenerator is therefore less than Tx prime. Tx, for example, is here. Tx the actual temperature leaving the regenerator is therefore less than Tx prime. The regenerator efficiency can be written as regenerator Hx H2 actual Hx prime minus H2 ideal. Actual ideal. If the specific heat is assumed to be constant, eta Tx minus T2 a higher efficiency can be achieved by using a regenerator with a greater heat transfer area. However, this also increases the pressure drop, which represents a loss, and both the pressure drop and the regenerator efficiency must be considered in determining which regenerator gives maximum thermal efficiency for the cycle. From an economic point of view, the cost of regenerator must be weighted against the saving that can be affected by its use.